Well, good afternoon. Welcome. This is the first time I've been to PNSQC. I've known about this conference for a long time. I work for Software Quality Engineering, and we produce the Star East and Star West testing conferences. And historically, this has always been the week after Star West. And after Star West, I just need to go home and rest. But this year there was a gap between our conference and PNSQC, and so I got to come and thrilled to be here. I've followed the history of the conference. I love Portland. It's a great city, and so tickled to be here. Rick gave kind of a brief introduction. He failed to mention something. It's required in my contract to mention that I wrote a book some time ago called Practitioner's Guide to Software Test Design, and I have to put in a plug for that. So there's the plug. You won't see it again. So testing trends and innovations, that's what we're going to talk about. So what's an innovation? Well, I used to, in the old days, I'd say I looked it up in the dictionary, but nobody actually looks things up in the dictionary anymore. I looked it up in the dictionary on the internet and found this. The word innovation means something new or different. It could mean something newly introduced or newly adopted. Or it could be a creation that is a new device or process resulting from study and experimentation. I'm going to use innovation in these concepts. Now, I've got a long list of things that I'm going to go through, and for some of you, some of these may be innovations. For some, all of them may be innovations. For others of you, you just look at them and go, nope, we do that, we do that, we do that, we do that. So, you're on this curve somewhere, and I'm not sure where, so I'm not claiming that everything I'm going to talk about is an innovation that would be brand new to you. But my guess is it would be brand new to somebody in the audience. So I made a big long list, and I've kind of organized them into 5 categories. We're going to talk about testing process innovations. We're going to talk about things that have come out of the Agile world, some education things, some technology and tool things, and some process improvement innovations. So that's where we're headed. So let's start with process, and I'm going to start with what's called the context-driven school. The context-driven school believes that test exists not to run the project, although sometimes we'd like to, but to provide testing-related services. We are a service organization. That's what testing is all about. We are here to serve. Another idea of the context-driven school is that it is entirely different for different test organizations in different projects at different times to see testing very differently. That a core practice or a core process in one context may be outlandish in another context. And this leads us to the idea, and this is my first soapbox of the day, that there are no best practices. Consultants love the idea of best practices. They put them in big binders, and they're happy to sell them to you for $1 gazillion, and they'll come and teach them to you and so on. But I don't believe in best practices. I believe there are good practices in specific contexts, but what's good in one context may not be good in another. I learned this a long time ago. Back when I was a newlywed, my wife came home with this new dress and modeled it for me and said, "Honey, how do I look in this dress?" Now, when I was a wee lad, yay high, went to Sunday school, and one of the things I don't remember a lot about that, but I do remember the story of Moses, who came down from the mountain with these stone tablets, and on it they had the 10 best practices. And I think that's what they were called. And I remember one of them was don't tell lies. Right? So that's best practice. We should always, now best means best, right? I mean, there is no practice better. And if there's no practice better, you don't have to ask yourself, well, is it good in this context or not? You can just always apply it because, hey, it's the best. That's what best practice means. So on this shoulder, I got you know, my little Moses guy up here going, "Do not lie." And my wife did not look really pretty. She didn't look good in the dress, you know. It's just, you know, it's a statement of fact. And I smiled and I said, "Honey, you look great in everything." Yes. So that was the thanks. I think that was the moment that I learned about no best practices. There are good practices in context, and we need to be sensitive to those. Now, it does make... What's that? Yeah, well, I'll meet him one day, and he'll give me the word here, I'm sure. So I think this is the part of testing, though, that's fun, is figuring out in this particular context, in this organization that I'm in this environment that I'm in this project that I'm in, what makes sense here? Yeah, a classic example. We talk about one of the best practices in testing is putting together a test plan. Before you go off and test, you know, you put together a plan. You figure out how you're going to test. You think about strategy and resources and training and environment and, you know, approach and all those kind of things. Now consider this situation. It's, what is it here, about 3:50. The boss comes in and says, "We got this software, it's got to go out today. We're shipping at 6 today. I need you to test it." Is the best practice in this case to go off and write a test plan? No. Right? It's to use the next 2 hours and whatever you got trying to find defects in it. Hopefully to find some showstoppers so that you can block the delivery of this thing and then have some more time to do something legitimate. So, context-driven. Second idea, trend and innovation, is the idea of checking versus testing. And this has been popularized by Michael Bolton. If you don't know Michael, the tester Michael Bolton, not all the other Michael Boltons. Then, if you don't know him, you should do a little research. But Michael has been making this distinction for the past while that checking is something that we do with basically the motivation to confirm existing beliefs. It's a process of confirmation, verification, validation. When we believe something is true, and we check to see if it's true, he calls that checking. And that's what we do when we do automation. When we do test automation, we believe the system works in a certain way, and we write some kind of confirming test to make sure it does. Highly automatable. Now that's compared, though, and contrasted with the idea of testing. Testing is something we do when we're trying to find out new information. We're trying to discover information that we don't have. When we're exploring, when we're investigating, when we're learning. And if you know about exploratory testing, this sounds a lot like exploratory testing, doesn't it? This is not automatable. This is where we use our brains. This is, for me, the fun part of testing, is turning our brain on and trying to test to see if we can find new things, undiscovered things, country we've never seen before. The third idea is crowdsourced testing. And we've done virtualization of hardware for a long time, but what about the idea of a virtual test team? Instead of just using a bunch of people who work for your organization, what if you could get thousands of people around the world together and marshal them into testing your product, at least for a little while? That's the idea of crowdsourced testing. Your organization defines a set of test requirements. You know, the kind of testing you'd like done, the scenarios, the environments, the various platforms. And then typically you go hire a test vendor, a crowd test vendor that'll help you put all this together. A couple of the big ones these days are UTest and Mob for Hire. I love the Mob for Hire name. What they do then is they do all the grunt work for you. They identify a pool of testers who have the kind of skills that you need. They assign your problem to these testers worldwide. They monitor the progress. They collect and report defects back to you. Those of you who have systems that run on many, many platforms over many different networks in many different parts of the world, you know, you could go to the boss and say, boss, I really need a round-the-world ticket, you know, so I can go to these places and test our product well. Or maybe you could just hire the crowd. Now, these crowd testers get paid on a per bug or per useful piece of information basis. And many organizations are using crowdsourced testing and using it very effectively. It's an innovation you should know about. Let me talk about the weekend testers for just a second. How many know about the weekend testers? Just a few. All right, the weekend tester model began in India with a bunch of testers who felt that they were essentially human, automated test tools. People gave them test scripts, and all their job was to do was run them. And they realized that they weren't really testing, and they weren't getting any better at their craft. And so they concocted this idea that they would have on the weekend. They would get together, virtually anyway, for an hour or two, and they would test some product. The way this works is one of the group chooses a product to test, assigns it out, makes it available. All the virtual testers spend the first hour or so of the session testing, and then they spend the next hour getting together, usually over Skype or chat or something, and they share their experiences. They talk about their challenges, the defects they found, the faults paths they went down, the traps they got caught in. And in doing this, they hone their skills and share ideas with each other. Like I say, this started in India, but it's really grown worldwide now. There are chapters all over the world of weekend testers. And again, I'm not saying that every one of these innovations is for you and you should rush right out and do it. But here's something you might want to investigate. See how this looks to you. Okay, now exploratory testing is kind of old news, but for some people it's innovation. So let me chat about it for just a second. The term originally was coined in Kem Kahner's book called Testing Computer Software, which is like 20, 25 years old now. And up until now, the best-selling book in English on software testing. I keep hoping mine will, eclipse it, but I don't think so. Exploratory testing is a simultaneous process of learning and test design and test execution. We kind of create a mental model of how we think the system should work, and we try it out. We don't sit down and pre-script test cases way in advance. We simply learn as we're testing. And if we're testing some piece of the system and it all seems to work fine, then instead of continuing on, the scripted test approach and ticking off tests that we're pretty sure are going to work, we go look at something else. We push and we prod and we poke. And we see what else we can find. Now, this is James Bach. He's kind of popularized exploratory testing, one of his many good ideas. And he said this once. He said, the classical approach to test design is like playing the game of 20 questions by writing out all the questions in advance. And I think just for fun, we should play this game. How many of you know the rules of 20 questions? 6, so I better explain. This is a game that adults typically play with children. The adult thinks of something, and then the kids get questions to try and guess what the adult is thinking. You get 20 questions, but they have to be yes-no answerable questions. Okay? If you could ask any question you wanted to, what would be the question you would ask? What is it you're thinking of? Exactly. And this game would be over pretty quickly, and it would be fairly dull, right? We'd call it one question. So it has to be yes, no answerable. And just for fun, we're going to play it here. We may not get to everybody, but I'm going to think of something in the universe. Give me a moment to do that. Oh, and if you believe in this stuff, I'm going to think really hard, send out brain waves. It'll make the game go faster. Okay, so I'm thinking of something. And could we start with you? And we'll just go up and down the rows, and you're trying to figure out what it is I'm thinking about. Now, this gentleman right here, we're just going to go up and down the rows. Oh, and you can always pass if you want to. There's nothing wrong with passing. Pass. Is it a solid thing? Yes, it's a solid thing. It is not a mineral. It is not an animal. Okay, it's solid, non-mineral, non-animal. Will you keep count for me? I appreciate that. Thank you. Not when I deal with it. It is vegetable. So how many questions we got? Okay, so in 5 questions we collapsed it from everything in the possible universe down to a vegetable. All right, let's keep going. Timothy. I don't know what that is. Is that like a potato thing? No, it's not one of those things. I'm not a botanist at all. It is a green vegetable. It is not lettuce. Not apple, no. Not broccoli. Not kale. Now, see, we're into this pattern of just kind of randomly guessing green vegetables, and maybe that's a good strategy, maybe it isn't. Maybe you could, figure subsets of green vegetables, but not your turn. Do I eat it raw? Sometimes, but I actually prefer it cooked. Pass? Yes. It's an organic vegetable. That's green and not an apple. Does it grow on a vine? I don't think so. Don't think it grows on a vine. How many questions are we up to? 14. Thank you. It is a green leafy vegetable. That is spinach. Very good. Congratulations. All right, how many questions? 16 questions. That's pretty good. I've had one group got it in 12. I've had groups that just never get it. They just kind of wander away. Last group, I did it last week. They asked if it was illegal. My kids and grandkids think it's poisonous, but anyway. Now, if you play this game well, each question depends on what? The previous questions and the answers to those questions, right? And if you don't play it well, you just kind of, is it Tupperware? You're going to wander off. Now, what James asks us to think about is the classic way we do testing. What if we played this game and I asked you to write all the questions out in advance? What if I handed you a little 3x5 cards and we passed all those out and collected those? How well would you have done? Would you have done it in 16? No. Okay. So this is the idea behind exploratory testing. The classic approach to testing is that one group thinks great thoughts about what should be tested, maybe hands that off to another group who thinks great thoughts about test design, who then hands it off to another group who actually writes the steps or the scripts, who hands it off to another group who actually run the tests. And what do we know about handoffs and over the walls and all that kind of stuff? It's terribly inefficient, isn't it? So these are ideas behind exploratory testing. Let me give you a couple quotes from James. He says, exploratory testing, as I practice it, usually proceeds according to a conscious plan, but it's not a rigorous plan. That is, it's not scripted in detail. He'll sit down and say, okay, now I'm going to click on File, and all those things that drop down under File, I'm going to spend the next hour exploring those things. Okay, there's what's called a charter. There's a time box. It's not just random, make it up, pound on the... I have a granddaughter named Cassidy, and when she was 3 years old, I turned her into a tester. I'd put her in front of the keyboard, and she'd go bang, 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 and then I taught her the mouse, and she'd wiggle it around and stuff. You would be amazed at what Windows does with totally random input. It's pretty interesting. But anyway, that's not what we're talking about here. It is planned, but it's not scripted, okay? To the extent that the next test we do is influenced by the result of the last test we did, we're doing exploratory testing. And we become more exploratory when we can't tell what tests should be run or will be run in advance of the test cycle. So that's exploratory testing. How many of you are doing this kind of stuff today? All right, halvesies. So it's an innovation for half. Exploratory testing has some really nice features. You can, first of all, do it concurrent with product development. You don't have to wait till that throw it over the wall moment. It's based on implicit as well as explicit requirements. I've heard so many testers over the years say, well, you know, I can't test this because I don't have the full, complete, consistent, concise, proper requirements document. Baloney. If you click on File and Print and a pop-up box shows up that has nothing to do with printing, do you need a requirements document to tell you that's probably a mistake? No. We know an awful lot about system behavior, okay, even without formal requirements. When we do exploratory testing, we basically create in our minds a conjecture of the expected results of what should happen. And then we try it. We see if we get that or if we don't. And then if we don't, we push a little harder. We push the boundaries. We try this and poke around. So that's what exploratory testing is all about. Hope you'll give it a try. All right. So that's the first batch of things. Now I want to talk about some trends and innovations that have come out of Agile. Two of those, first of all, test-driven development, and then acceptance test-driven development. So let's start with TDD or TFD. Again, how many are doing this? Small number. All right, so here's the idea. Before our and we're talking about unit level testing here. Before our developers write a single line of code to implement some function or some module, the first thing they do is to write the test cases for it. And I don't mean just think about them, they actually write them in a programming language or in a scripting language. And then they run all of those tests. And should those tests at that point pass or fail? They should all fail. Why? Because the module that it's testing doesn't even exist yet. If those tests pass, you know you've got serious problems with those test cases, right? If they'll pass there, then they'll pass with bad code. So the first thing that those tests should do is fail. Then the programmer starts building the functionality of that module or that unit. And they add a few lines of code, and then they run the test cases again. And a few will pass, most will still fail. So they add more code, and more code, and more code. Every time they add code, they run the test cases. And it's easy because they're all automated, right? It's not a manual thing. And finally, they get to the point where all of the tests pass, at which point we declare victory, right? And go have a party. Because the requirements for that module are implemented in the tests. The test cases tell us what that module is supposed to do. And when they all pass, by definition, we're done. Now that assumes, of course, that you've done a good job of writing those test cases, but I'm sure that they do. Now, if we do this test-first development and then we add something to it called refactoring, that's the official definition of test-driven development. Refactoring just means to go back through the code and clean it up. If you've duplicated code here and there, get rid of that duplication. If you've just written some clumsy code, clean it up, make it nice. Schedule that in your process to every once in a while, go back and refactor the code, make sure it's nice and clean. It's so that's, it's something that you'd be proud of showing publicly. So that's the idea of TDD, test-driven development. The goals of TDD are these. We get more accurate specifications. Again, the specs are not in some formal requirements document. The specs are in the test cases. It becomes a useful specification because we know it's more correct and complete and concise than those classic ones. It helps focus the mind. As the developer, if the developers first thought about test cases and then they write the code, they have those test cases still cooking around in their brain. And so they typically remember those special cases and edge cases and things where we used to find defects. Helps them write clean code. And it prevents the creation of an inventory of things that don't work. Those of you who went to the talk this morning on lean, one of the things that kind of modern day accounting has fooled us on is the value of inventories. We have accounting people in here. Inventories, how do they show up on the balance sheet? Asset or liability? Assets, absolutely. Your inventory is an asset to your company. All those washing machines that you built, that you haven't sold, that are out in that warehouse gathering dust and the leaky rain is coming through, that's an asset? Well, I don't remember who that Italian guy was, like in the 1400s, 1500s, who invented double entry bookkeeping. But since then, we have all believed that inventory is asset. Lean comes along and says just the opposite. Lean says no. Inventory is liability. That stuff rusting in the warehouse, it's a liability. What about your requirements document, your 500-page requirements document? You've built the doc, but you haven't built any code yet. Asset? Liability. What about that bug tracking database that lists all those defects you haven't fixed yet? Asset? Liability. Okay? So these are some ideas from lean manufacturing that have snuck into software development, and I'm glad they have. I think they put us on the right track. We don't want to create inventories of things that we haven't implemented and that don't work. Now, the opposite of TDD is ATDD, Acceptance Test Driven Development. And this is on the high end. This is like system testing stuff. The process, the cycle that we use is that developers, testers, business analysts, users, stakeholders of all kinds get together and discuss what the system should do. And then they distill that down into a set of acceptance tests. Again, we don't distill that down into a formal requirements document. We write a set of acceptance tests instead. The developers then go off and write the code, and then we demonstrate that code works against those high-level acceptance tests. And again, it's like, washing your hair. It's, shampoo, rinse, repeat. You do this over and over and over until finally all of the acceptance tests pass, in which case it's time for another party. You can tell I'm kind of a party guy. So that's ATDD. Again, just like TDD, acceptance tests are written before the code is written. And for those old people like me, we've been preaching this kind of stuff for decades. We've been begging and pleading for developers to write unit tests, either before they write the code or as they're writing the code or shortly after. And mostly that plea has fallen on deaf ears for a long time. Then this guy named Kent Beck came along and invented this thing called extreme programming, and he said, oh, by the way, you guys really should write your test cases first. And everybody went, oh, yeah, okay. So much for my powers of persuasion. And again, just like the TDD at the low level, ATD tests take the place of the formal requirements that we're used to having. All right, so that's what I want to say about things coming out of Agile. My next category is education, and we have seen in the last few years the emergence of lots of really good books, just chosen at random for the -- position up there. Sorry about that. Again, it's in my contract. I have to do it. Let me just mention some other books. Secrets of a Buccaneer Scholar by James Bach. Anybody read that? A few. Just one of my favorite books these days. It doesn't have much to do with testing, but it's really the story of kind of James's life and some techniques that he has developed as an adult to learn and improve and gather new skills and just be better at his trade. And it's just full of good stuff, and recommend it highly. If you're looking for kind of testing 101, if you're really brand new to testing, my favorite book is Systematic Software Testing by Rick Craig and Steve Jaskell. Now I got in the interest of full disclosure, Rick Craig works for the same company I do. So I'm pitching his book here a little bit. A marvelous book called Lessons Learned in Software Testing by Kaner, Bach, and Petticord. If you haven't seen this, it's a marvelous book. Should look at that. I mentioned already Testing Computer Software by Kim Kaner and some other folks. It's in its second edition now. I understand that Michael Bolton's working on the third edition and should be out shortly. A book that every tester should read. Another one of my favorites is How to Break Software by James Whittaker. How many of you know Whittaker or know of Whittaker? Okay. He's a crazy man. I love him. He's just amazing. He wrote this little book. It's a half-size book. It's about 120, 140 pages long, called How to Break Software. It is one of these books that will literally change your life as a tester. I have kind of 3 levels of books. There's the don't bother to read these, they're junk. The next level up is, hey, this is pretty good, but get your company to buy it. And then the third level is, this is really good, spend your own money on it. Whittaker's book is a spend your own money on. It literally will change the way you look at software testing. One of the things that it does, one of the marvelous things that it does, is, people like Bach and others, they have this kind of California style, go explore, look, find, and Whittaker's book tells you where. Whittaker had a gaggle of grad students study defects for a number of years. And he has found 14 basic categories, 14 basic areas where defects tend to hide. And if you want to find them, exploratory testing is good, but not just random exploratory. Go look at the 14 places he says most defects hide. Like I say, it's one of those books that will change your life. I recommend it highly. An original book, Glenford Meyer's book, The Art of Software Testing, came out in like 1978 or 79. He's one of the grandfathers of formal testing. He and Boris Beiser and 1 or 2 other people essentially invented software testing in the middle to late 70s. Myers lives up here somewhere. I think he's in Portland. I've tried to get him to come and speak at the STAR conferences, and he's just not interested. He runs a little electronics company. I think they make like spook stuff, and he just has no interest in testing at all. Which, might be a handy piece of information to have. You can get out of testing, apparently, and and continue to be successful. So, Brian Merrick's book, The Craft of Software Testing, is a good one. Rex Black has a number of books. Managing the Testing Process is my favorite. There's a lot of good stuff these days. So there's, let me see how many on my list here. 9. How many of you have read all 9 of these books? Raise your hands, would you? 8? 7? 6? 5? 4? All right, I'm going to stop right there. It strikes me that if we want to be considered professionals, if we want to be recognized by our organization as valuable contributors, that we need to be educated. There's a little story I tell. Certainly I wouldn't wish this on anyone, but imagine that you're kind of waking up and you're not sure where you are. And there are kind of lights passing overhead. And you realize that you're lying flat, but you're moving. And somebody kind of peeks over you in a doctor's outfit and a mask and says, I'm Dr. So-and-so, you've been in a car accident. You have a serious head injury, but I'm the neurosurgeon. I'm going to take good care of you. Don't worry. And in a moment of clarity, you think back on today. And you say, Doc, what's your favorite book on brain surgery? And the doc says, never read a book on brain surgery. There's a lot of good stuff out there, and I think we ought to read it. I think we should be more educated as a group than I think we are. I used to do what we call test process assessments. You could hire a company to come in and make an assessment of your testing process, give you some suggestions on how you might do it better. And we used to have a kind of a standard set of interview questions, and one of my favorites that I always asked testers was, how many books on software testing have you read? And the answers frightened me. They really did. So that's my plea here. There's some really good stuff out there, And that might be an innovation for some of you. Now, big testing conferences and middle-sized testing conferences. First of all, I'm the program chair for Star East and Star West, and now we have a new one called Star Canada that we did this year, and we're going to do again next year. You know, we attract 1,000 people to these conferences, and I like big conferences. There are others, you know, there's like Eurostar, which is the big one in Europe. STANS is big in Australia and New Zealand. There's a couple conferences in India. I just came back from a testing conference in Malaysia, which was really kind of an eye-opener. The government of Malaysia has just decided that Malaysia is going to be the next outsourcing place to go. That they're going to wipe out India and China and Eastern Europe, and Malaysia is going to be it. And they're dumping literally millions of dollars into tester training, into test labs, into all kinds of things. It was an interesting place to visit. The JAS conference in Japan brings together 1,000 Japanese testers every year. I like big testing conferences, and I like them because, first of all, you just get an unlimited number of participants. You can focus on a large number of topics. And there's just kind of a critical mass that we achieve when we do these kind of conferences. You might like this idea that participation is not generally required. You get to sit there and listen. Okay? You're not asked to work or, you know, do much, put forth much effort other than just listening. So it has a generalized focus and a kind of a lecture style. This is kind of a mid-sized conference, and I'm a real fan of these size regional conferences. I just spoke fairly recently at SQUAD, which is the regional conference in the Denver area, similar to PNSQC. I'm a real fan of these conferences, and you know, it's easier to come to these than the big ones. Although, you know, we have Star West at Disneyland. It's hard to, you know, it's hard to beat that. Unless, of course, like me, this time I took 3 kids and 8 grandkids with me. So it was a festival. I want to talk a little bit about small testing workshops. These small testing workshops are very different than things like SQUAD and PNSQC and STAR and Eurostar. First of all, attendance is by invitation only. You have to kind of make yourself known. Make it known that you'd like to come. And typically they limit the participation to 15 or 20 people. They focus on a very small set of topics, unlike the big conferences, and participation is required. Typically these small conferences require each of the attendees to give at least one talk, present at least one paper. The learnings are collected and published and then available to everyone. There's nothing copyrighted here. Anything you hear you can take away and use. Here's a list of a bunch of them. The Austin Workshop on Test Automation, the London Exploratory Workshop in Testing. It all started with this one, LOST, the Los Altos Workshop on Software Testing. There are all kinds of things. WHOPR, the second to the bottom here, Workshop on Performance and Reliability. Again, if you're interested in these, Google around. You may find something. And if you don't find something in this area, maybe you should start one. You know, get some folks together and start one of these. I wouldn't see it at all as a competitor to PNSQC. I think it'd be a nice complement. Yeah, Los Altos, California. It's just right up the road from Milpitas, you know. Okay. There's a bar called the Brass Rail, but I don't. That was a former life. I don't even want to talk about that. Used to hang out there. All right. Another thing in terms of education is what I just call freedom of the press. A.J. Liebling, who was a U.S. American journalist back in the 1940s, had a great phrase. He said, "Freedom of the press is..." And that was true, you know, in his day. But today, this is what today's press looks like, and everybody's got one of those. Right? You can blog and tweet and, you know, make yourself known and maybe even obnoxious, you know, to your fellow testers. There are a lot of good testing blogs around. These are just a few of my favorite authors. ones that I follow on a regular basis. You might want to start one yourself and just toss out your ideas and share them with the community. The press is pretty free these days. Everybody's got one, and I think you should use them. Now, our company, Software Quality Engineering, sells testing training. And so one of the key innovations that we're not too keen on is what's called open source training. That is free training. And this is one you should know about. There's a whole, a marvelous set of videos and materials that Kem Kaner and James Bach have put together. It's called Black Box Software Testing. You can just Google that and find it. I don't know if this URL is current or not. I haven't checked recently. Is this current still? Okay. Their motivation is, they're smart guys and they want to share it. They've got good ideas and they want to share it. They want the community to get better. And James makes enough money and Kem makes enough money that, they just want to do this for the fun of it. Anybody here a volunteer that consults and teaches? All right. Okay. So there's all kinds of online stuff. You don't necessarily have to go out and buy a book. There's a lot of free online stuff that's really good. And I see it as a marvelous innovation. Again, I think that it's important for us as testers to take steps to improve our own knowledge and skills and education. I see too many testers who kind of come with this idea that, well, if their organizations wanted them to be smarter, they'd buy them a book or they'd send them to a training class, they'd send them to a conference, that somehow it's the organization's responsibility. And I just never bought into that. I think it's our responsibility. Now, if you can get your organization to pay for it, cool. But I think it's our responsibility to improve our own knowledge and skills. All right. Let's now go to technology and tools. This is the fourth section. And I want to start with open source tools. And, there's a lot of bang for the buck here in open source tools. 5-10 years ago, if somebody had come to me and said open source, I would have thought about two guys in their garage on Saturday, with a few beers, cranking out some code. That's kind of what, the level of quality that open source was. But boy, that's not true anymore. There are all kinds of marvelous testing tools. There's development tools like Eclipse, there's the system testing stuff, there's performance testing, there's unit testing. If you want to find kind of the current list, I found that opensourcetesting.org is a good place to go to find kind of a list and reviews of the latest thing. And I recommend open source much more than I ever could before, just because it's gotten so good. Now, open source, of course, does not mean free. It means free to acquire, but then there's training and help and consulting and assistance, and there are companies popping up right and left making bundles of money providing those kinds of services for people who are adopting open source. Maybe that's an area you want to get into, is make your million that way. But open source tools are really good these days, especially in the system testing and performance testing area. You should look into those. How many are using open source testing tools? Okay, again, less than half. Again, I'm not saying that you should do this or you must do this. I'm saying this is an innovation you'd want to consider. All right, virtualization. The idea of virtualization is simple. In the old days, every time we had a different operating system or a different version or a different this or a different that, we'd get a box to run that in the test lab. I remember visiting a place one time. They said, would you like to see our test lab? And the answer is no. It's always the same. It's a big room full of computers, But I'm always gracious. I say, oh yes, I'd love to see your test lab. Sincerity is the key. Once you can fake that, you got it made. So I'm always sincere. Yes, I'd love to see your test lab. And I went into one time, and it was probably, about square footage of this room. And they had machines all around the walls. And I quickly counted them. I said, I'll bet you you supply your software on about 23 different hardware-software combinations. They said, why, yes, we do. How did you know? I said, well, I just counted. You know, it amazed me you would have so many machines. I said, isn't this expensive? They said, well, compared to what? There was a day in their history where they became what they fondly call a CNN moment. They were featured on CNN when, you know, some new version of their software just didn't work. And lots of customers were unhappy. And so they feel it's far better to have, you know, to pay for 23 machines and be able to test each one of those hardware-software combinations before they send it out again. Well, a few years ago, that's really the only choice we had. Today we have virtualization, where we can take multiple physical machines, get rid of those, and just have one big box and run virtual machines inside it. And there's lots of people that you can get this kind of software from. I've just listed a few here. But virtualization is an important thing for testers to consider. First of all, it lets us rapidly provision, that is, rapidly stand up a test environment. Studies have shown that typically between 30 and 50% of your testing time is just spent loading up a machine, you know, finding the machine, getting it all cabled together, getting everything loaded up. Another nice thing about virtualization is if you find a defect, you can simply push a button and it'll make a copy of that machine, you know, everything in it, so that you can later come back and debug and test. The reduced power costs alone can pay for all of this kind of stuff. Years ago, I worked for a mini computer vendor called Data General. Anybody old enough to remember Data General? All right. I was there from like 72 to 78. And we had a big super secret development project going on. And it was called the Tower Project. It was called the Tower Project because it was actually done not in the factory, but in the Tower Hill apartments in central Massachusetts. And the reason it was done in those apartments was when you paid the rent, utilities came out of that. Utilities were paid. And it was a moneymaker for us. We had more machines there sucking more electricity, you know, than the rent cost us. So these guys were pretty sharp. But, you know, there are reduced cost things to think about here too. So virtualization is a cool thing. We talked about virtualized test teams in terms of crowdsourcing, and virtualization of the hardware is cool also. All right, one more thing in technology and tools, and that's testing in the cloud. How many are doing this kind of thing? All right, let me ask a couple of questions here and take a survey. How many of you work on systems that are hosted in the cloud? Okay. How many of you run your test software in the cloud? Okay. Less, but still a number of you. Okay. And there's all kinds of combinations. You know, there's application in the cloud and testing in your hardware boxes. There's the other way around, testing tools running in the cloud, testing an application that's in your data center. And then there's all those, you know, the other combinations of those things. This is an interesting area. We don't know a whole lot yet about the different kinds of challenges, the things that are new and different when we're into cloud testing. But the idea of cloud is simply that, you know, you can just go, you know, rent a bunch of computers for a fairly short period of time. You don't actually have to buy them and install them and house them and maintain them. I did a little survey one time. You could rent a small computer in the cloud for about 10 cents an hour. You can rent an extra large, gigantic machine for about $1 an hour. And, you know, Coke is $3.10 a can at the hotel where I'm staying. You know, so this kind of gives you a comparison here. We're going to see more of this. And again, you know, I know I'm plugging Star East and Star West, but as program chair, I'm always looking for new speakers on new and interesting topics. And if you'd like to be considered as a presenter, you can either email me directly, lee@sqe.com, or go to our website, sqe.com, look for a tab that says conferences, click on that. A little drop down will pop up that says be a speaker. We'd love to hear from you. Okay, I'm sure that in this audience you have some things to say. Now, that's the upside. Let me tell you the downside. I'm working right now on the Star East Conference program for next year. I have 42 speaking slots. I have 208 proposals. So just know that the odds are against you. But I was back in New York the other day, and on the side of the bus, you know, it had a big ad for the lottery. It said, if you don't play, you can't win. I'm pretty sure that if you don't toss in a submission, I will not pick you. And I'm pretty sure of that. So, you know, toss in something, and I'd love to hear from you. And again, you know, good stuff always rises to the top. So if you have some good ideas, please submit. We'd love to hear from you. All right. Final one of my 5 areas here is testing improvement. And I want to talk about something, first of all, called TPI. Anybody here heard of TPI, Test Process Improvement? Like 3 or 4. This was created by a couple of guys over in the Netherlands, Martin Paul and Tim Koeman. They are renowned testers in Europe. They worked for a company called Equip at that time. And they built this model on how to do test process improvement. It came out in 1997. The alleged English translation was 1998, but Martin says it's written in Dunglish. That is part Dutch and part English. You know, there's some sentences in there. They are clearly English sentences. They have English words and English syntax, and you have no clue what they mean. So if you get this book, you'll just want to, you know, go at it with that. If you have a question, send me an email. I spent hours with Martin over the years, you know, learning what it means. Let me tell you a little bit about the model. The model defines 3-4 interesting things. The first idea is called key areas for process evaluation and improvement. There's 20 of those. Under each one of those key areas, there are up to 5 levels of maturity. Now, unlike other maturity models, not every level has 5. They didn't feel a great need to kind of force that. So some have 1 or 2, some have 3 or 4. Under each level, there are things that they call checkpoints, which are really evaluation questions. So you answer these checkpoints or evaluation questions to decide which level you're in for a particular key area. And there are a number of testing models around that are similar to this, at least up to this point. But one thing I like about TPI then is it has what we call improvement suggestions. It says, if in this particular key area you're at this level, this is what you might consider next. Unlike other maturity models, it doesn't say you must do this next. It just says you must consider it. You should consider it. It's a kinder, gentler kind of model. Okay, so let me show you what some of these areas are. Here they are. Test strategy, life cycle model, moment of involvement. When do testers get invited to the party? How many of you get invited really late? Okay, like the requirements are done and the design's done, the code's done, right? And then they say, oh, we better wake up the testers and throw it over the wall. Well, that's kind of the lowest level of maturity in the TPI model. All right, test specification techniques, metrics, tools, office environment. You might say office environment, that doesn't seem too important, but I did a consulting gig. Actually, we did a TPI evaluation for a big organization. I'm not supposed to mention them by name. Let's just say it's a large stock exchange located in New York City. Okay? Does that help? And when we got to office environment, we found a group of testers who came to work and put on their parkas every day because their offices were in the computer room, in the machine room. And that didn't strike me as a particularly friendly thing for the people involved. It was good for the machines, you know, to keep them cold, but not too good for the people. Okay, so there's a whole bunch of stuff. What they call low-level testing is what we would call unit testing. So it asks you to look at each one of these areas, and like I say, for each one, it has a bunch of questions that you can answer that tell you which level you're in. And I found this very useful over the years because, you know, lots of people, they kind of have this feeling that their testing process isn't as good as it could be, but they're not quite sure how they compare against others. And then they're not really sure where to start. One of the nice things about the TPI model is that interspersed or intertwined with it are priorities. Like, you probably should think about this before you think about that. Okay, you probably should do this before you do that, because it's a foundation for what comes afterwards. And lots of people, you know, it's kind of like when CMM came out. Everybody wants to go to level 5 immediately, because that's like nirvana. The TPI model, first of all, says you don't have to go to the highest level if it doesn't make sense. You know, we ask you to think about risk and reward, you know, cost and benefit, and do what seems appropriate in your organization. It's just, you know, it's a kindler, gentler model. I like it. Here's what typically comes out of an assessment. Here are the key areas, and these A, B, C's, and D's are the levels. Okay, notice they don't all line up, again, because of priority. Some things need to be done before others. And so when we do an assessment, what we do is, this is part of the output, part of the deliverable, is we kind of show people where they are. Okay? Then in terms of improvement, the idea here is that you start on the left side and you march to the right. So the ones that aren't covered here, commitment and motivation and test process management, those are probably the ones you want to work on first. Again, because they're a foundation for things that come later. So I like the TPI model. Now, it has a competitor, and that's called TMMI. TMMI is really popular in Europe, not so much here. We're still pretty much cowboys and cowgirls, I think, in this country. And when it comes to process stuff, you know, we don't need no stinking process. Especially don't need any improvement process. The thing about TMMI is it was built by a bunch of people who were committed and use the CMMI process. And so these merge together. TMMI has the same number of levels, and it hooks to CMMI. It again has, you know, maturity levels and assessments and standards and all these kind of things. It's something you should know about it. This I stole directly out of the advertising brochure. I just want to read it and laugh a little with it. TMMI has a rapidly growing uptake across Europe, Asia, and the USA, and owes its popularity to being the only independent test process measurement method. How many of you even know about this thing before I mention it? Like 3. So that's rapid uptake, according to them. But it is very popular in Europe. It's something that kind of everybody knows about over there. And so, you know, here's the classic, if you know CMMI, you know, the classic 5 levels and the arrows and stuff. And it's got initial, managed, defined, measured, managed, and optimization levels. You know, very similar to the CMMI model. All right. Well, that's what I want to talk about today. This is what I see as trends and innovations in the areas of process, things that have come from Agile, education, technology and tools, and process improvement. But I want to give you with this, I want to talk about future innovations in just a second. But I need to, again, you know, give you disclosure. This is me, 1969. I worked on a little project called the ARPANET. Anybody heard of the ARPANET? Whatever happened to that project anyway? I was at the University of Utah. We were machine number 4 to go onto the ARPANET. And that was like November or December of '69. And my job, one of my jobs, was to get bits to go down a wire and come back. Well, not to come back. I hope they'd come back. My job was to send bits down a wire. And I had no clue of the future of that thing that I was working on. For me, I was a young punk kid grad student just trying to get bits to go down a wire. In astronomy, there's a term called the event horizon. It's how far out you can see. Okay? Imagine you were on some planet and it was much bigger than Earth or much smaller than Earth. You know, where is the horizon and how far out can you see? Personally, my event horizon has always been very limited, very short. I worked on this little ARPANET thing and had no clue where it was going or where it could have gone. So, you know, people ask me sometimes, they say, well, Lee, what do you think the next big innovations are? And I go, I don't have a clue. You know, if I did, I'd be buying stock and I'd already be rich and, you know, sitting in the Bahamas somewhere. In grad school, I went to grad school with a guy named Alan Kay. Do you know that name by any chance? He went off and invented a few interesting things like Smalltalk and GUI interface, worked at Apple and did some cool things. Kicked around Disney for a while in the Imagineering department. But Alan said this. He says, the best way to predict the future is invent it. And I like that idea. You can spend lots of your energy, lots of time, lots of brain cycles trying to figure out what the future's all about. Or you could take those same cycles, that same energy, and just go off and invent something. Now, if you've been following Dilbert the last day or two, anybody looking at Dilbert? Dilbert's having these great ideas, and Dogbert just looks them all up on Google and finds they've already been invented. And, you know, Dilbert's kind of bummed right now, but maybe he'll get over that. But I like what Alan says. The best way to predict the future is just to actually go invent it. Let's see, what time is it getting to be, and when do we have to end? Oh, we got mucho time. Okay, so let's just take a couple of minutes, if you'd like. Toss out what you think some future innovations are going to be. If I were to come back and give this talk you know, in a year and didn't want it to be identical, what new things would I add? Anybody have things they want to toss out? Innovations that are coming in terms of software testing. Say again? 3D printing, and how is that how is that related to testing? We're going to have to test it? Okay. Okay, do you guys know about In-N-Out burgers? You don't have In-N-Out up here, do you? No. They're making their way up? Okay, well, I'd like to 3D print In-N-Out burgers. That'd be a good deal. All right. White Castle, is that the big deal up here? Oh, that's a Wichita. What's the best burger in Portland? Burger who? All right. All right, we digress. Innovation. Okay, better relationship, closer relationship. The direction Agile is taking us, right? None of this us versus them, throw it over the wall kind of stuff. Okay. I mean, that idea is already here. It usually takes, what, 40 years to take technical ideas and actually get them spread through organizations. So it's going to be a while. But I think that idea is here. Anybody got some ideas that haven't even popped up yet that you think could be innovations in the future? Please. Managing complexity is going to drive it. Okay. Okay. Let me recap what you've said so far. So, his comment. Tell me your name, Steve. So Steve's comment is that systems are going to get bigger and bigger and more complex. And as testers, first of all, as developers, they're going to have to figure out how to deal with that. And secondly, as testers, we're going to have to figure out how to deal with that complexity. And it just popped something into my mind I want to share with you. I ran into this somewhere along the road. It's called James Reason's Swiss cheese model of failure. And it kind of works like this. Imagine a piece of Swiss cheese and it's got holes in it. Okay, the simple systems that we used to work on, that was kind of the defect model, right? There were defects, there were holes, and stuff could sneak through. As we build more and more complex systems, as we build them out of components from various sources with various histories, and maybe not knowing much about their defect history. And then we assemble those modules together, those components together, and we do it over essentially unreliable communications networks. Does that sound like a goofy idea to anybody here? Okay, that we build systems out of individual component parts from various vendors with various revision levels and histories we may not know about, and we connect those together and try and make them work together, and we do that over a non-secure network that fails every once in a while. That's what we're doing now, right? Right? Anybody know about like SOA, service-oriented architecture? That's what that is. It's what we're doing, okay? Anyway, the Swiss cheese model is, now imagine each one of those components, has some Swiss cheese holes. And when does the system fail? Only when a certain set of holes lines up together. And as testers, how are we going to find those? It's getting harder and harder. This is going to be a big challenge. And I don't know whether we're up to it or not. Let me tell you a quick downer story here. Always end with a downer, I think, is the good advice. I ride on airplanes a lot. In fact, I'm going to show you something I'm proud of here. Oops, it's not there. This is my little bag that I carry. It's got the Delta thingy on it. You see what that says? That 2M? What does that mean? 2 million miles. Just got this the other day. Okay? No. It's just I've only been in one plane crash during the 2 million miles, so it's not too bad. But I ride on planes a lot, so I'm interested in airplane crashes. And, I kind of follow, and let me tell you a quick one. ValueJet 692 crashed into Everglades a bunch of years ago. I don't know if you remember that. Killing everybody on board. The cause was a fire in the cargo hold, which ultimately incapacitated controls of the plane, and the pilots couldn't control it. It crashed. But that's not the cause. What caught on fire? Well, it was a bunch of things called oxygen canisters. The little demo, what's that? Oxygen generators, thank you. The little demo they give when they say, the mask will drop down. You may think that there's a big can of oxygen somewhere in the back of the plane, but there isn't. There are little canisters, they look kind of like pop cans, about that size, up in the overhead gizmos. And what those do is they flick, and they have some chemicals inside that mix and generate oxygen through some kind of chemical reaction. And when they do, they get really hot. So there's some rules about shipping these as cargo. The rules are, basically, you don't. You either have to put a special cap on the oxygen generator so that it can't, be triggered, set off, or you have to empty them. It's the only way that it's legal to ship these things on planes. ValueJet, in their maintenance facility, had some canisters laying around. and they needed to ship them. And they didn't do the right thing. There were actually 3 different people who, first of all, they have a little card that says exactly what the steps are to go through, and the person's supposed to follow that exactly and then sign off. 3 different people signed off, yet none of them did it right. They ran out of red caps, red labels to show that it was charged, and so somebody used green labels instead. Then somebody else came along one day and found all these canisters just kind of laying around on a bench and said, well, tomorrow the big boss is going to come and inspect the facility. They want to make sure it's clean. So let's wrap all of these in bubble pack and put them in a box on the shelf. And then a few days later, after the big inspection, somebody came along and found all these and said, oh, I guess we better ship these. And so they wrapped them up and put them on the plane, and that was that. It's the Swiss cheese model, isn't it? At any point along this 6 or 7 layer, set of Swiss cheeses, had somebody done something different or done the right thing, that plane wouldn't have crashed and those people wouldn't have died. This is the complexity of systems that we're dealing with these days. Almost every major failure in hardware and software we see these days is something like this. It's not just one thing. It's a Swiss cheese thing. And I think you're right. Dealing with this complexity in the future is going to require innovation. I don't know how to do it yet. And I don't know that any of us do. But that's certainly a place we'll want to look. Well, so here's your homework assignment for the night. I know you've got nothing else to do. You might want to just think for 5 minutes, as you ride the bus or the trolley or the whatever home. Think about what future innovations you would like to see, and and try and expand your event horizon a little past mine, and see what you come up with. All right, well, that's what I wanted to say today. I appreciate your joining me. Really appreciate the invitation to come to PNSQC. Like I say, my first time here. Tried to get here over the last decade or so, haven't been able to. My email is pretty simple. I'm old, they got to keep it simple so I can remember. lee@sqe.com. If you have any comments, questions, things you want to chat about, love to hear from you. Thank you.